Trimble and the Building Point teams. Today's video, we're actually going to go through some processing of slope data for a parking garage, but the same can be done for an ADA ramp or really any slope analysis. Collection has already been done, and we've covered in a couple other videos how that's done, but it is important to mention that with FieldLink and either the X7 or X9 is how you're going to be able to achieve this. One is because the hardware on the X series scanners is they self-level to 3 seconds, which kind of corresponds to 0.3 millimeters at 20 meters. Most of the scanners on the market aren't going to level to nearly that degree, and will give you some error when they level to like 18 seconds or so. And so that is really what allows you to do a good floor analysis and a slope analysis. It is also where you can register and georeference the data, so you know it's in the correct spot when you're either using a model or creating a model and comparing back to. So workflows, I'm actually going to cover how to do a slope design, essentially creation in SketchUp, which you can get, I think it's business, what they call it, or pro for $2.99 a year, or premium for $6.99, which includes the ability to actually import the point cloud. You can create a model there. It actually isn't completely needed, but I do like some of the deliverables we create with the scan to model comparison. That's why I'm going to do that first and then show you that. So that'll be the first part of this video. The second part is going to be how to bring in that data and actually do that analysis and create those deliverables. Realworks data prep is kind of covered in other videos as well too, like how do you clip it up, do a floor extraction, etc. But we're going to import the slope we create, do an inspection cloud, and then we're going to do a surface to map inspection as well as create contours and lines of that. So with that, I guess we can get started. So moving over here to SketchUp, you can actually see another slope I have here. So before we even jump into actually creating this mesh, you can see this is actually a full point cloud along with kind of the RWP that was created in there with different coloring, but here's the intensity, along with some map views. So let me turn that off again. You can see I can actually create a point to measure that up with, but usually what I like to do before I even go into there is get a decent understanding of the slope. So here is that same project already opened up. In Realworks, I can come in here and actually just take a few sample lines to get an idea of that slope, which is about 2.7 degrees. So if you're going to do degrees and you want to get the kind of the rise over that run of that entire length, remember if you do the arctangent, you're going to actually want to convert it to radians. You can get that answer here, and instead of using degrees, actually convert to radians initially. So coming back to SketchUp, 2.7 is about what I have. All I do here is generally what I'll do is turn this off, create a what looks like a map or a rectangle of what is going to represent the floor of this, and you can see the slope hasn't actually been created. I could create a point to this point by just hitting X and then drawing this up. But usually what I like to do, because I think it's a little more accurate, is create a line with the arctangent of that degree slope. So I've already done that and created this line, I believe, as an arctangent of like 2.7, but you can see that's about 5 foot and 5 inches, which corresponds to about a 2.7 degree slope, which is what we saw. So usually what I'll do is I'll create this line and then bring this up. So make sure I'm tied into that. So here you can actually see it's brought that up to the slope. I could actually very quickly do an inspection where it actually shows me this very well. So I can actually see where it's going to be down and out. Now, the inspection on SketchUp is actually done to the visual standpoint, so it's not actually as accurate as what you'll get in what you get into Realworks. So with that, I'll actually be pretty happy. I'm going to delete these other kind of from the ramp one. And I'm going to export out this ramp so I can bring it into um, bring it back into Realworks. Now, a couple things to note is we'll call this ramp 2, IFC. Because I created this in reference to this, or I created this ramp in reference to the scan data, it should hopefully come into the right spot. I could do the same thing in AutoCAD, Revit, whatever design platform you want, or I don't need to do it at all is the other thing. So let's keep moving on. So come back here and I'll import that ramp 4. Where did I export that ramp to? We'll try that one more time. To documents. I usually like to put it in downloads because then I can delete it right afterwards. So I'm going to call this ramp 2. So bringing this one in here, you can actually see, let's see where this pops in. See if it's in the right spot. Let me turn off this section box, and then there we go. So it actually did look like it brought in the right spot. I will usually bring it outside so I can do this and rename it ramp to IFC. So with that, and I already have this point cloud, I can actually come in here and do a 3D inspection. So we'll run this, and this is usually what I like to do the most. I can kind of refine what's going in here and what I'm looking at. So let me filter out some of these really far away points. You can actually see it dips down almost quite a bit there. We'll go to from blue 3. We'll go here to 3. Kind of rerun this one more time. And so what I have here is actually a scale bar where things are higher and lower, and you can actually see inside that column, which is usually kind of expected, it's going to drop down. Now that 3 inches is a bit larger than what I usually like, which is about 2. But here you can see a high area here to kind of a low area in the middle. Let me go actually about 2.5. Do this real quick and this side view. And so you can see it actually flips down to making that red one more time. So maybe that 2 inches is a little bit too small. Let's see if we can keep that to about 3 inches and filter it. Nah, so we'll make this a little bit larger and keep this with, or we'll do that 2.5. So this is a great way. So I just did that analysis. This is a decent slope where you can actually see there's no offset, or it's not like one side on the top side is high and one side on the bottom side is low. It actually does do a pretty good comparison showing you where it's high and low. You can actually see some of the waves here as well too. This is going to show you the entire floor though, which if I'm the concrete guy, or sometimes even the GC, it's not always necessary or what needs to be done to make spec. I am going to create this as a inspection cloud, so I can export that out with those same colors as an IFC. That's our first deliverable, or I can actually come back here and simply just take images with that scale bar, which I also like to do. So that's kind of your first step. Moving on to actually doing some other surface analysis, surface to model inspection. So let me rename this map inspection ramp 2. And then let me turn off that. So I have this IFC, I have my floors that are extracted, again, pretty quick to do that. I can't do a surface to model inspection, but if I keep this turned on, along with like my ramp 1, or it'll actually kind of almost lie to me, telling me I can do, let me turn off this other one, a twin surface inspection. But really what that's going to do is just give me the ability to define that plane. And so this is the same spot where if I were to just create a plane from the scan data, I could have a best fit plane to that and kind of usually get a decent slope, but it will be dependent on the points I click. So I don't actually like to do this. What I actually will do instead is turn off this other one, create a, instead of going from the point cloud to create this, I'll actually do a geometry creator um, from the IFC I imported, just because I feel like that's a little bit better rather than going to the point. It's just going to fit this to the plane. Let me try that one more time. Sometimes I have to do a couple button clicks to make sure that this kind of makes it big enough to what I want. And so all I did was actually go from a mesh to creating a plane here, which will fit that kind of slope that I like. So one thing I didn't cover because the IFC was already brought in the right spot, I can actually move this IFC by essentially going move mesh and then kind of dragging it to fit. I like where it's at, but this is how I would line this up, high and low for, I kind of let it until it zoom in, turn off this other object until it splits pretty well. And this will give me a good indication. Now, I could have this if I georeferenced it to georeference to elevation as well too. But usually I'm just trying to see the relative high and low spots. So this is what I'd say is good enough for an analysis. You can see that's how I can move that. The other way and why I showed you that is so I can show you this as well too is I'll come back down here to ramp 2 from this plane that I created. I can move this the same way, but it's actually going to be a different movement. So I'm going to go ahead, go back to model and go to modify geometry. So I can do the same thing. Again, this slope is already set and the elevation should be good, but we'll see that here in a second. So usually you don't want to look at the actually very extents, but this looks pretty good. So bring this up and down a little bit. A little too high, kind of let it split in between. And then let's see if I change this color, if it pops a little better, and it does. So I'll be happy with where that is. Again, I can always kind of readjust it if I need to as well too. So between these two, I can now select it, go into inspection and do a, rather than twin surface inspection, do a surface to model inspection. Again, the value of this is going to create a, let me go back here, a similar result to that inspection cloud, but I'm going to be able to do a couple more things with that. So define it. So I'm only looking at kind of the slope area. Preview that. Again, resolution is just creating a block 24 inches wide that you're seeing through here. Here you can see I actually have a kind of an inspection map that I can then, if I like, and this is a good, and I'd say this is a decent overall because I kind of have the same amount above as below. I can come in here and do an inspection map analyzer, or I can just create this as a map already. Creating the map, I can export a TIFF, which is nice, but usually what most people will actually want to do is send topo lines, either isometric curves like you see here where I can actually preview this. I can send those, which would be a georeference. I can export those as a DWG, DXF, or IFC, which is nice. So I'll actually create these. I can also come back here and do volumetric, or not volume and surfaces, section and shift lines. The value here is that these are actually going to create multiple slices of lines where I can actually see the high and low of each one of those. So this is, I think, a better representation of how that floor is doing. This allows me to kind of stick away from, if I want to if there's any anomalies or if it's near columns or edge of concrete type stuff. So you have a couple different ways, and we have other videos actually covering how these are made pretty quickly. But this is, I think, a good showing of that. So I'll do horizontal because these, or hopefully, should be pretty close across the way. More so than the vertical, which actually they should both fit pretty well because the vertical should have that same slope. But we'll do horizontal here. So we'll do an interval 70 inches. I can do multiples where you can see this. Export sections or create all, and that'll actually create all those lines. Let me close that one and create my map as well too. So let me then come in here, create a new little group called ramp 2 where I can bring in all these deliverables. So there's that one, and then map section reference, ISO curves, ramp 2. So I could export this and then bring it in as a TIFF just by coming in here and actually coming to export map. So this would be ramp 2. It's going to create a TIFF image with a text file to import that. A lot of times what a lot of customers will like to see is actually these lines all together. Now to do this the most efficient way, I will usually bring them all into one folder. And then select them all, turn them all on, export them as a DXF. We'll see if horizontal ramp 2, export that. And then, oh, yeah, we're gonna have to use a DXF. I figured as much. Now, please, there might be another way to actually export that as all these lines at once, but usually this is what I know to what will work in this video very quickly. Horizontal ramp 2. And so set this, because DXFs aren't defined by units. Usually I do inches because that's a good way to, a pretty standard thing to see within most kind of AutoCAD environments. So with that, I have my whole horizontal DXF. I can actually, what I'll do is bring this into Connect to kind of show you that deliverable. Again, you could bring the same, I say deliverable, you can just bring the same thing into AutoCAD or Revit, as well as take those screenshots and measurements, but generally this is going to give you a good idea. You can do every line like we did here, or you can do particular lines if you just need to show, let's say, every 10 feet rather than every 70 inches. It allows you to, I don't want to say skirt by local anomalies, but like what you saw here and what you can actually see from, if I look at the line here, or if I look at the actual collection of the data here, like dirt and stuff, you may not want to actually clean this all up, but you can actually run your line, so you're not including that. So within Trimble Connect, you can actually see all these. I can come down here and essentially turn these on and off as needed to. So this is going to be a little bit of repetitive data as I've brought this on and off, but let me turn some of these off. So I hit the wrong side, we'll go here, turn off there we go. So here you can see there's a inspection, there's a reference, comparison, and then a kind of a combination of both lines, where if I zoom in, you can actually see the deviation of what's there at those intervals and those slices that I set within Realworks there. So those are my kind of 3 deliverables, meaning I can hand over that DWG, hand over this TIFF image along with scaled information that can be said, or that inspection cloud like you see here in Realworks. This inspection cloud, I can actually come back and export out as ramp 2 inspection as an E57 and include, if I come back here, include that inspection kind of colors with it. And what that'll do is actually import those colors the same way as shown here. One other thing I forgot to show is actually these ISO curves. We'll, we'll export these as well too, just to show what they look like as well in Realworks. To contours. And so this is essentially creating contours in I'd say almost a difficult way to do because it's a sloped environment. So you kind of do have to go, I'd say, a little, I don't want to say like creative, but you do have to go in with a little more work than you would in most of the floor inspection or the flat ones. Creating that ramp or just doing what you see, what you saw actually during this video and the creation of it. So let me come back here. So coming back to it, actually, this is a bug I forgot about. Switching it to US survey feet instead of the fractional inches will allow you to create ISO lines or contour lines without weird naming structures. And then I should be able to come in here. Let's turn these on, turn this back off. So if this works now, export. And here we go. Those as well. Let's see, turn some of them on and off. You can see text there too. But those contour lines will come in along with obviously what we did for the horizontal ramps, if you like those as well too. To get that TIFF image in is actually something I would bring back over to SketchUp and then save a SketchUp file to bring them all in at once. I believe. Let's see if I have. Don't have one quite yet. But I could bring that actually TIFF image in. Now, the final thing and one we didn't discuss, this is for analysis of post-pour. So doing analysis in Realworks, creating those contour lines, those inspections as well. If you know the slope angle, you can actually create that beforehand and bring, like you can see here, this is actually an import of that same IFC that we created from SketchUp. Just by going to more projects import, I can bring that in. Make sure I have it here. Ramp 2, it's already there. But once that's imported, because it was made from the scan file and actually set up in the same georeferencing, it'll actually come in exactly where it's at. You're seeing a section box along with that slope. I can then come into an inspection and run that on essentially everything that's in that section box compared to that slope. So it's going to be a little bigger than I probably want. But I can bring that back in as well as start to turn down, or I guess bring down the inspection area it's analyzing. So there we go. We can do that. Turn off all the gray area, and then usually what I like to do is turn off solid model. So this is corresponding. Now these are absolute values, but we do know that it kind of slopes down, and I can adjust that as well too. So again, this reporting, I can do an image with the scale bar. I can't actually export this as I would in Realworks, but it does show me in the field. By bringing these lines over from what do we have here? We'll bring these back in. Bringing these lines into Connect, I can use Connect AR to actually overlay these so I can see on the field where they're high and low as well too, and then start to mark them out if I needed. But yeah, please reach out to your nearest building point representative for additional training. This is pretty intense. We have many videos showing flat work and vertical analysis. This is essentially how do you get into a decent slope analysis that I came up with. So thanks.